we are on 4.3. And I think, looking ahead to next week, I think we have 4 sections before the quiz. So I think we have another section on Monday, and then review on Tuesday, quiz on Wednesday is what I'm thinking. I remember looking at. Today we're going to look at what we call the remainder theorem, but more specifically, we're going to be looking at synthetic and long division. Okay, and what that is going to allow us to do is determine if a factor or a zero is a solution to a polynomial. And so we're going to start off with long division, okay? And I will tell you this just straight up, long division is probably not going to be our go-to method in the majority of the time. But there are times where you have to do long division based on what kind of polynomial I have. But the majority of the time, we will use synthetic division. And so as we look at long division, I'm going to spend a little bit of time with it. But the majority of the time, what we're going to be working with is synthetic division. Okay. Now, long division, you can remember all the way back to like your grade school days where we would do a number like this, right? 38 divided by 7. Well, today we're going to do it with polynomials, but if we kind of remember the process, if I go back to just numbers, right? 7 does not go into 38 evenly, so we have to figure out how many times it goes in there. And so we would say 7 goes into 38 5 times without going over, right? So then we're going to multiply those two together. And then we're going to subtract 35 from 38. And this number right here is what we call our remainder. And the reason I show you all of this is because today, one of the ways that we're going to write our answer is to kind of show what all of this means. And so what we're saying here is that 7 is not a factor of 38 because there's a remainder, right? If there's a remainder, then it's not a factor. And so when I write my answer back out here, we call this the divisor, we call this the quotient, we call this the remainder, and we call that the dividend, okay? And so 7 times 5 plus 3 equals 38. All of those numbers can be put back together to get us back to where we started with, which was 38. So that's with numbers. But what we're going to do it now is we're going to do it with polynomial, okay? So let's look at an example of, once we took 5 times 7, we got 35, right? But then what did we have to do with that 35? A polynomial here. And I'm just going to go ahead and put it in long division form. They're going to give this to you a lot of different ways. Sometimes it might be written out as like big polynomial divided by x minus 3 or whatever we're trying to divide by. But when we do long division, this is the kind of the format we want to put it in. Kind of want to put it in that division form like we do with long division. And so I'm just going to go ahead and start here. So we're taking this big old polynomial and we're dividing it by the polynomial that we have out in front. Okay? And here's what I'll tell you about long division. It's kind of a long process, so hence long division, right? But it's a repetitive process. So we're doing the same steps over and over and over again, but we just kind of have to understand what those steps are. And so the very first thing that we're going to do is we're going to say first term to first term. What do I have to multiply x by to get to x cubed? How much? X squared, right? Because we've got exponents. And this is assumed to be an x to the first here. And so to get our exponents together, we're going to add our exponents together. So 1 and 2 makes 3. And so x squared times x would be x cubed. But then I also have to take x squared times negative 3. So essentially, I'm taking x squared and distributing it to both of these parts to get to here. Now, I'm going to keep coming back to this. Well, we had to subtract it. So if I were to subtract this whole thing, I could change the signs on everything to look like that. Okay, so kind of we're going to distribute a negative throughout. So that should make my x cubes disappear. And then 2x squared plus 3x squared would be 5x squared. And then we're going to bring down the next term and the sequence and the polynomial. And here's where it gets repetitive. We're going to do that one more time, okay? And we're going to keep doing it until I don't have any more terms left at the end down here, okay? So I'm going to bring down the negative 5x, and I go through the whole process again. What do I have to multiply x by to get 5x squared? 5x, okay? So we're going to put that up here. And whatever number I put up here, we have to distribute to these two things. So 5x times x is 5x squared. 5x times negative 3 is negative 15x. Okay, and what I like to do here is here I kind of distributed the negative, but that's essentially what we're doing here. And I'm just going to make this a negative and this a positive. So we got to make sure we change the signs on both of those terms on the bottom. And what that should always do, it should make these two disappear. And then a negative 5 plus 15 would be a 10x. And then we got to go one more time. Hey, Ryan, question? It's long, right?
That's my question.
Yeah. Okay, one more time. X times what gives me 10x? 10. Okay, so we're going to put 10 up here. 10 times x is 10x. 10 times negative 3 is a negative 30. And we change our signs. And when I do that, once again, my x's disappear. That first term should always disappear. And then negative 6 plus 30 would be 24. And because we don't have any more terms left out here, that is our remainder that's left over. Okay. Now, writing our answer here, in some cases, what they're going to ask us to do is they're going to ask us to write our answer like this. Dividend equals divisor times the quotient plus the remainder. The dividend is what we have underneath, okay? So that's going to be x cubed plus 2x squared minus 5x minus 6. The divisor is what we're dividing by out in front. The quotient is the answer that we got, the top part up here. It's the answer to a division problem, plus the remainder. So we're taking all of those pieces from the long division and we are putting it into an answer. Okay, now, you might say, well, why do we do all that? That seems like a lot of work, and I get it, right? But they just want you to show the relationship that's going on here. If I were to take this binomial times this trinomial and do all the multiplication, and then add 24 to the end, it would end up getting me back to here. Now, we're not going to actually do all that multiplication because that would take time, but they want you to kind of draw that relationship in to kind of see what all of these things mean. Okay, what are we really trying to do? Questions? Okay, I'm going to do one more long division with you. Okay, one more. And then we'll be done with long division for the day today, other than your assignment. And I'm probably many long divisions, like on your quizzes or tests, because we're going to be doing synthetic division most of the time. Okay, so on this one, what I'm showing you is I have the same exact polynomial underneath. Okay, I did not change the polynomial. But this time I'm dividing by a different factor. X plus 1 is a factor. And I want to show you why this one's a little bit different and what happens on this one. All right, so first step once again. What do I have to multiply x by to get to x cubed? X squared. Okay, once I have it up top, I'm going to take x squared, I'm going to distribute it to x in 1. And then I'm going to change, don't forget to change your signs. That's probably the most common mistake that we forget to do here. We forget to change our signs. What that does is that makes those x cubes disappear. And then 2 plus negative 1 or 2 minus 1, however you want to think of it, would just be 1x squared.
How does the x squared stay there? It's 1x squared and 2x squared.
Because we're combining like terms, right? If I do 5x plus 3x, I would get 8x, right? We don't necessarily get 8x squared if we were to do that. So when we add or subtract like terms, then the exponents just stay the same. Okay, because that would be your common term. Good question. Okay, and then once again, this is where it gets repetitive, guys, right? Because we're going to say, what do I have to multiply x by to get 1x squared? Just x, right? So that's going to come up here. And then I'm going to take that x, and I'm going to take x times x, which is x squared. I'm going to take x times 1, which is 1x. And I'm going to change the signs. And once again, the first term in that should disappear every time. If it doesn't disappear, then I've done something wrong. Negative 5 and negative 1 would make this a negative 6x. We got one more term that we got to bring down. And we're going to go through this one more time. Okay. X times what gives me negative 6x? Negative 6. So that's going to come up here. We're going to take this negative 6. We're going to distribute it to these two pieces. And that's negative 6x minus 6. Now watch what happens. When I change my signs, positive, positive, the x's not only disappear, but so do the 6's. Okay? So we're left with a remainder of 0. Okay? If we get a remainder of 0, that means this is a factor of this polynomial. Okay? And so there is no remainder. So if I take this times x plus 1, that would get me back to my original polynomial. There's no remainder that we got to put back in there. Okay? And you could, so if you were to write this out, it would be this equals this times this. I'm not going to take the time to write all that out again, but this is my dividend equals the divisor times the quotient, but there's no remainder, so we don't have to add the remainder back in. Okay. Okay, now side by side here, I'm going to show you the same problem, but we're going to do it with synthetic division. Okay, and I know you guys remember synthetic division from Algebra 2, and it is much, much simpler and quicker and easier. That's why we're going to go to synthetic division almost always. Okay, so a lot of times, this is how your problem is going to be written. Or it may have a division sign in there, or something like that. Okay, so just writing the division problem a little bit differently is all it is, right? It's the exact same problem we just did on the left. But this time we're going to do it with synthetic division. Okay, so when we do synthetic division, we always make this box out here. The box is always going to be what I get when I set this equal to 0. Okay, so if I had x plus 1 here and I set that equal to 0, then inside the box, I'm going to put a negative 1. Okay, unless there's a number in front of the x, then it would always be the opposite of this. Okay, and very seldom will there be a number in front of the x, so most of the time it'll just be the opposite of that. Okay, next to the box, we're going to put all of our coefficients. So we have a 1, a 2, a negative 5, and a negative 6. So we're going to list those out. 1, 2, negative 5, negative 6. And we're going to draw a line down here. We'll leave a little bit of space, because from here, all we have to do is multiplication and addition. If we can do multiplication and addition, we can do synthetic division. Basically what we've done is we've gotten rid of all the exponents and the variables and all of that, right? And that's what cleans this up a little bit and makes it a little bit easier to work with. Okay, so the very first thing is we're going to bring down the first number, which is 1. And we're going to take whatever is in the box and we're going to multiply those two things together. So I'm going to take negative 1 times 1, which is negative 1. And then we add straight down. And that gives me 1. And synthetic division is pretty repetitive as well. After I get this number, now I'm going to go back to my box. I'm going to take negative 1 times 1, and that gives me negative 1. And when I add those two together, I get negative 6. And when I take negative 1 times negative 6, I get 6. And there's my remainder of 0. So the last thing in that row will always be your remainder. And so what I always do here is I draw a line here to show this is my polynomial, this is my remainder. Okay? Now, we need to write it as a polynomial, just like we did over there. So when I write this answer as a polynomial, we're always going to drop it down a degree. So my original polynomial had a degree of 3. So now we're going to start with a degree of 2, 1 less, right? And we're going to go 1x squared. You don't necessarily need to put the 1 there. Plus 1x, or just x, minus 6. And that's our quotient. And that's the same quotient we got over there. And the fact that this is a remainder of 0 once again tells me that it's a factor. It would be one of the zeros, one of the factors of that polynomial. You won't always get a remainder of 0, okay? If you get a remainder of 0, that's usually a good thing for a lot of stuff that we're going to do. Okay, questions on either one of those before we move on? I know long division is a long process, okay? And it's one that takes a little bit of time to kind of get used to. Synthetic division is one that we definitely need to know synthetic division, because we will use that a lot, this chapter especially. Okay, another way that these could be written. I'm just showing you a lot of different ways that some of these problems might be written. Okay, so there's my polynomial, dividing by x plus 3. And there's some things that you really have to watch out for when you do synthetic division. Okay, first of all, we're going to make our box out here. What number is going to go in our box? Negative 3. Okay, the opposite of our divisor. if I set x plus 3 equal to 0, I would get negative 3. So negative 3 goes in my box. Now here's one of the things that you got to watch out for. My polynomial here starts with 4, right? And it goes 4, 3, but then notice it's missing an x squared. So if it's ever missing one of the exponents, all exponents have to be accounted for. So we have to include that in our numbers. So if there is no x squared, we're going to go 2x to the fourth plus 7x cubed plus 0x squared. We have to have something there to account for the x squareds, plus 1x minus 12. If you don't put that 0 in there, you will not get the right answer. Okay? You will get a completely different answer and it won't be right. So you got to be really careful about your exponents. Are all exponents included? This time it's a no. And then we go through the same process. Negative 3 times 2 is negative 6. There's a add straight down. Negative 3 times 1. And then this last number is always my remainder. We don't get a remainder of 0 here, and we won't always get a remainder of 0. And when I write my answer here, we're not going to always write it like that first one that we wrote where we have to write all of those terms out. We're just going to write our quotient, our answer. What's the answer to the division problem? Okay? So we started with a degree of 4. We're going to drop it down by 1. So we're going to start right here. 2x cubed plus 1x squared, or just x squared, minus 3x plus 10, with the remainder of negative 42. And that's our answer. So this is not a factor, right? If I don't get a remainder of 0, then it is not a factor. Okay, you guys feel pretty good with synthetic, Brian?
On the homeworks and the quizzes,
Mhm.
do you want us to write it out the long way or
O- Only if it asks for it, and it'll say in the directions to write. And I think we won't have very many like that,
Okay.
where we'll do it that first way. Most of the time, it'll be more like this.
Alright.
Yeah. All right, we talked about the remainder theorem at the beginning of the lesson. What is the remainder theorem? What does it mean? And obviously, it's going to talk about the remainder, right? That's why we call it the remainder theorem. Basically, it's another way to evaluate a function. And it may not be the best and easiest way to evaluate a function, but once again, we're seeing the relationship that's going on here. So if I were to evaluate a function, one way to do it is something like this, okay? And, oops, if I get, I went ahead and put a 0 here, and I shouldn't have, but if I get 0 when I evaluate, then that means that number is a 0 of the function that I'm given, which means it would cross the x-axis at that point, or touch the x-axis at that point. So we're going to give you a polynomial, and I'm going to show you kind of the relationship that's going on here. Our polynomial is f of x equals x cubed minus 6x squared plus 11x minus 6. Okay, now here is the one big difference here, okay? If I said, let's evaluate f of 1, then I don't do the opposite here because it's not a factor. The only time we do the opposite if it's written as a factor like x plus 1. This is just a number. This is a number that we are checking. So in this case, the number that we are putting in the box is 1. We do not do the opposite here. So that's another thing you're going to have to pay attention to. Is it a factor or is it a number that we are trying to evaluate? My coefficients here Everything's included, 3, 2, 1, 0. So everything is part that we want. And when I go through, I get a remainder of 0. Okay, and that remainder right here is what I would get if I were to plug 1 into this function. So it's just another way of evaluating the function. The remainder is the same as what I would get if I plugged 1 into this function. And some of you might say, well, it would be a whole lot easier just to plug 1 in. And I probably would say in a lot of cases it would be, right? But those two things are related, okay? They are the same thing. Kind of like what we talked about the other day, where we could look at the graph and we could say, if the y value is 0, then it is a 0, right? So it's just another way of finding the 0. If I were to plug in -2, I'm going to use the same numbers here. I'm going to bring down the 1. When I plug in -2, I get -60. So what we would say here is that 1 is a 0. -60 is not a 0. So the remainder tells me a lot of information. It tells me if that number is one of the zeros of that function. Okay? If I get a remainder of 0, 1 is one of the places that that graph will touch across the x-axis. If you want to graph it, you can verify that really quickly by putting it into the calculator and making sure that it crosses the x-axis at that point. Okay, let's just do that real quick so you guys can. Oh, sorry, -2. My fault. That's a great question. I wrote the answer, not the. That's a great question. I should have said -2. That's totally my fault. It's a good question.
I was confused.
Because in some cases, do what? Question?
No, we put to, that where it says 1 is -0, 60, 1 is -0, why don't we have?
Oh. Okay, x cubed plus 2x squared plus x plus 2 is my polynomial. Okay, and this is why synthetic division also will come into play. I can do -2 on my calculator. I can look at the graph and I can see, does this graph cross the x-axis at -2? But is there any way I can use a graph to determine if I and -I are solutions? Not really, okay? And so I can't really use my graphing calculator for that. So that's why graphing calculator is a great tool, but it's not the end-all and be-all of everything that we are able to use. So we have to have different routes of being able to use some of these things to determine if it's a solution or not, okay? So all we're trying to do here is say yes or no. So out of those 3 zeros, what would be the easiest one to use first? -2. And I'm going to show you why we want to use the easiest one first. I don't want to start with I, because it's going to get big and nasty if you use I or -I to start with. So use the nice integer number that we have. 1, 2, 1, 2 are my coefficients. We get a remainder of 0. So we say yes. -2 is the 0 of this function. If I were to graph this, basically what this would look like. I'll just do it. This is what it would look like. You're going to have a graph, and I don't know exactly what it's going to look like. Something like that. Okay? It's going to cross the x-axis at -2, never cross it again. Okay? And so that's why we can't verify all of the zeros on our calculator, because there's only one real zero. How many zeros do we have to account for? Well, there could be 3. All we're trying to determine right now are I and negative I also zeros. So I'm going to put I in the box. Now here's the great thing about using -2 first. I don't have to go back to the original because I had a remainder of 0. If I didn't get a remainder of 0, I would have to go back to the original. So I can take what I have left over right here, and I can bring that down. So 1, 0, 1. Those numbers are going to be a whole lot better to work with than that longer, bigger polynomial. So I'm going to bring down the 1. I times 1 is I. 0 plus I is I. I times I is I squared. But what is I squared really the same as? -1. And so 1 plus -1 is 0. So is I a 0? We would say yes. And then once again, we got to try a negative I out here. I'm going to move what we have left down to here. I'm going to bring down the 1. 1 times negative I is negative I. I plus negative I is 0. So all 3 give me a remainder of 0. So all 3 are yes. Okay, but once again, if this was not a remainder of 0 here, I wouldn't be able to keep getting it smaller and smaller. I would have to go back to the original if it didn't work out like that. Okay. Show you a shortcut. You're going to have some questions like this on your homework and on your quiz and test in this chapter. And originally what this is going to look like is a problem like what we've done the last couple of days. And what method would I look, if I asked you to factor and solve this polynomial, then what method would we probably go to here to factor this? Grouping, right? Anytime we have 4 terms, grouping is probably going to be our go-to. But what I'm going to show you here real quick is that grouping is not going to always work with 4 terms. So 4 terms, grouping would be our go-to. But what we talked about when we did this is the 2 parentheses end up having to be the same, right? And if I were to take an x squared out of this, that leaves me x plus 4. These 2 don't have a GCF, so the only thing I could take out is 1. And that leaves me an x minus 6. These 2 are not the same, so grouping doesn't work here, okay? You can always try it, because that's kind of our go-to, but here, grouping does not work, okay? It doesn't help us. So I'm going to show you a really quick shortcut here that you can do, and you're going to use your graphing calculator for it. Okay, we are going to solve it first. So let's put this into our calculator. Let's graph it, and let's see what our solutions are going to be. The factors are the three sets of parentheses that we could multiply back together to get us here. And they're always going to be the opposite of those solutions, right? So if -3 is a solution, x plus 3 would be its factor. Because if I set x plus 3 equal to 0, it gives me -3. So we're kind of working backwards a little bit, right? -2 would be x plus 2, and this one would be x minus 1. If I multiplied these three factors together, it would get me back to here. We're not going to do all that multiplication to verify that, but trust me, it would be back to that polynomial. And that would be what we call our factors. Okay, so they're written a little bit differently. Factors are always written with parentheses. Zeros are always written as x equals whatever the number is going to be. Okay, one more problem here. And I'm going to show you this one mainly because I want you to see, once again, the relationship of why we might use synthetic division and where it would come into play. Okay? So if I tell you that x equals 1 is a solution or a 0, find the other zeros, okay? And I know that you could go to your calculator here, but I want to show you that, once again, the link between these two and understand what's going to really happen here and how I can do synthetic division to get where we need to be. Okay, so we're going to use synthetic division here. I'm telling you that x equals 1 is a solution of this polynomial, okay? No doubt about it, it is. So we're going to go through synthetic division. I'm going to put a 1 in the box, not -1 because it's not a factor. It's just 1. I'm going to bring down the 1. -2. Okay. And if I tell you that it is a factor, I better get a remainder of 0. Okay? Non-negotiable. If I don't get a remainder of 0, I have done something wrong because I already told you that it is a 0. Okay, now here's what we're going to do. I'm going to take what's left over here and I'm going to write it as a polynomial. Well, we started off with degree 3, so this would be 1x squared minus 2x minus 8. If I asked you to factor this, what would x squared minus 2x minus 8 factor into? What could we do? Okay. -4, 2. Yep. See ya. So those would be my two factors. If I set those equal to 0, I would get x equals 4, x equals -2. And those would be my other two zeros. Remember here that we started with a cubic polynomial. So we had to account for 3 zeros. 1 is already given to us. We found the other 2. If you graph this, guess where it's going to cross the x-axis at? 4, -2, and 1. You could put it in the calculator. You could verify that. Okay, but that's where synthetic division comes into play. That's how we can use synthetic division to find our zeros. So quadratic formulas and quadratic equations are still going to come into play here sometimes. All right, assignment for today. (10 through 50 by 5).